Hello everybody, and thank you for joining me once again. Root Beer here, and today I thought we'd begin to take a look at the grade 11 contest, the Hypatia contest for 2015. So let's take a look at the contest right away. We have our usual preamble. Well, that's nothing new to us if you've seen any of the previous Hypatias. If not, of course, always take a look and read through this, especially if you're going to attempt the contest yourself. It's always important to read the preamble. But I'm assuming that you guys have at least read the preamble, tried this contest yourself by clicking the link down below, or tried the Hypatia in general, so you guys know what's going on. Alright, question 1. Each Hypatia railway train has one engine car followed by some boxcars in a straight line. The distance between consecutive boxcars is 2 meters. The distance between the engine car and the first boxcar is also 2 meters. The engine car is 26 meters in length, and each boxcar is 15 meters in length. The total length of a train is the distance from the front of the engine car to the end of the last boxcar. Alright, fair enough. A part. What is the total length of a train with 10 boxcars? Okay. Well, it's going to have one engine, 10 boxcars, and then we're also going to have to count up each of these little connecting 2-meter bits. So let's go to our paper. So we'll have an engine up here. We'll have boxcar. And a boxcar. And we'll keep going like this for 10 boxcars. Okay. So the engine, 26 meters in length. And 10 boxcars each have length, what was it? 15 meters in length. Okay? So each of these are 15 meters. And then all these connecting bits. And you could test it out if you're unsure of how many connecting bits. It'll be the same as the number of boxcars because we have an engine. It's going to be 10 little 2-meter connecting bits. And if you doubted that, you could say, okay, what if we had one engine and 2 boxcars? Well, we have 2 little connecting bits. What if we had a third boxcar? We'd have 3 little connecting bits. So it's not hard to see that if you have 10 boxcars after one engine, you will have 10 little connections. Okay? That's the sort of claim you can make, because you could probably just draw yourself a nice picture. If you had enough paper, if you had enough room in the answer booklet, you could draw the picture with 10 connections. That's really not what we're here for. That's part of it, but this is a light bulb question. We just want our final answer. So the total length is 1 times the 26 meters plus 10 times 15 meters for each boxcar, plus 10 times 2 meters for each connection, plus 26 plus 150 plus 20, and that's going to be equal to 196 meters. Let's just double check that. 150 plus 20 plus 26, 196 meters. Okay. I'll put a box around it in a moment. It's always good to distinguish your solutions on in the written style. Okay, B part. A train has total length of 2,015 meters. Well, that makes sense. We're doing the 2015 contest. Eventually, a 2015 would just have to show up on the contest at some point. How many boxcars does the train have? Okay, so now we're going backwards. In the last one, we knew we had 10 boxcars and we figured out the length. Now we're going to have to figure out the number of boxcars from the total length. So, put a little box around our final answer from the last time. Alright, so for B part, we don't know how many boxcars there are, so we're just going to give it a random number named n. I chose n as opposed to something like x because n will hopefully at least subconsciously remind us that we should be looking for an integer value, a positive integer value. You can't have 17 1/3 boxcars, for example. So if we get a fraction, hopefully we'll know we did something wrong. Okay. So we have an engine, followed by a boxcar, followed by a boxcar. So we have n boxcars, and that'll mean n connections. So if we get an equation for the total length of the train in terms of n, we know that we could then rearrange that and solve, knowing that the total length is given as 2015. So there's always one 26-meter engine. Each boxcar is 15 meters in length, and each of the little connections is 2 meters in length. So we're going to get 26 plus 17n. 15 plus 2, 17n. N, not m. So then we get this equation for 2015 in terms of n. (2015) minus 26. That's 1989, and hopefully that's a multiple of 17. And it is. So we have a total of 117 boxcars, and that's exactly what we were asked for in the question. Alright, on to the last part of question 1. You'll notice it's a written style question. C part. In the diagram, a southbound train with 14 boxcars crosses the border between Canada and the United States at a speed of 1.6 meters per second. Okay. Determine the length of time in seconds during which a portion of the train is in Canada and a portion is in the United States at the same time. Okay. So we don't want to split in half or anything like that. We want to know the second part of the train has crossed the border so that'll be the front part of the engine here. We want to know the second that crosses the border, and then the entire time from that moment until when the end part of the train crosses the border, then part of the train is in Canada and part of the train is in the United States. So a little bit of conceptual thinking there at the start. We need to explain that as we write up our solution. So we got ourselves a brand new sheet of paper. Okay. So as long as the front of the engine has crossed the border, at least some part of the train is in the U.S. And if the last boxcar has, at the very end of the last boxcar has not crossed the border, then at least some part of the train is in Canada. All right. So we're looking exactly how long it takes. If the train starts with its front at the border, how long does it take until the very back of the train crosses the border? That's what we're looking for. So we can either view this as the train moving across the border at a speed of 1.6 meters per second, or we could instead view it as though the train were fixed. I know it's hard, it's a little more difficult thinking, but you know, you're supposed to be upper year high school students doing these contests, so this shouldn't be out of the realm of possibility of your thinking. Think of it rather than the train moving, think of the train as fixed, and the border is moving. I mean, think about it when you're driving in a car. Okay, either you're being driven or you yourself are driving. It doesn't feel like you're moving. You're sitting in position, and things are going past you and going past you. And if you were on the train, if you were riding on a train, maybe you've ridden on a train, you watch the scenery go past. You see a border coming up way in the distance, and you're just sitting there, and the border appears to go past you. You know, if you were crossing over the border between the U.S. and Canada, it would be as though the border is approaching you. And so you aren't moving relative to your way of thinking, but the border line is approaching you at 1.6 meters per second. So how long does it take for this imaginary line, this line that is the border, how long does it take for it to pass the entire length of the train? Another way of thinking of it is, if we start like this, here's where the back of the train is. How long does it take for the back of the train to move this distance? Because then it'll be at the border. So that's another way to think of it. Now x, The unhappy length that we have to travel is the length of the train. And the time that it takes for the very back of the train to travel this distance and end up at the border will be x divided by 1.6 meters per second. So all we need to do is figure out x, which is the length of the train. Well, the train has n equals 14 boxcars. And we know from part B that the train will have length 26 plus 17n. Well, that's 26 plus 17 times 14. And we can get out our calculators and figure out this exactly. It's going to be 264. And so once again, as I said, the time we're looking for is just going to be x divided by, so this should be meters, it's x divided by 1.6 meters per second. Well, now we know what x is. Okay, so 264 divided by 1.6. 165 seconds. These meters cancel out and the seconds come up on top. $165 seconds. Now, I've seen some other people try this question, and what they did was they said, sure, you get an answer of 165, but if the train front is exactly at the border, that doesn't count as being in both countries. You know, you've gone right up to the border. Just like if the very back of the train, the very, very back is touching the border, that doesn't really count. So what they did is they would subtract off a second for each end, or a half a second, or something like that. But I caution you against doing things like that. You don't know how finely the markers want you to measure, what sort of room for error there is. Our equations give us a single, nice, quick, exact answer. Now, you may conceptually disagree with this, and that's okay. And sometimes that can lead you to the right answer. But something like that, you are just picking a number out of thin air. You say, okay, I'm just going to take off a second for each end. Why are you taking off a second for each end? Why not half a second? Why not 2 seconds? Why not 1.6 seconds for each end? You know, that way you definitely know there's a meter for each. Actually, it's not quite a meter. That way you know there's a little bit of wiggle room there. When you realize that you are making an arbitrary choice by saying I'll subtract off a second for each end, or I'll subtract off a thousandth of a second just so that I know each part is in Canada and the US. For a written question, you need to be justifying everything. So to make an arbitrary choice like that, although you're explaining it perfectly fine, you are explaining that, well, I don't really think that the front of the train being at the border counts as being in both countries. You're still making an arbitrary decision, and you can lose marks. Mathematics is supposed to be exact, and these contests are heavily reviewed. So I can assure you there is, I would say 99% of the time, there is an exact solution and a definite way to get it. There is no picking numbers out of thin air to satisfy your conception. And so that's just a public services announcement. I saw some people who did this in C. They said, you know, the very end of the train on the border doesn't count as being still part in Canada, so I'm going to subtract off some time. Don't be picking numbers out of thin air. Don't be making arbitrary assumptions about what constitutes being in Canada or the United States. If you think you see a way to solve the problem and your equation spits out a nice, healthy, whole number, odds are you're right. Okay? That said, don't be worrying too much about it. I think in the marking room, they would likely lose maybe a mark. So unless you're going for perfect on these sorts of things, it's not that big of a deal. Just a little tip to try and improve yourself is do what the question asks, not what you think the question should be asking. I guess would be the best way to phrase it. But that's enough yickety yak. I've already spent way too much time talking about that. That was question number 1 on the 2015 Hypatia. I look forward to question number 2. Hopefully you do too. And as always, I'll see you guys in the next video.